Hi guys, in this video I'm going to be discussing how to find the equation of a plane in three-dimensional space. So first of all, let's just talk about what a plane actually is. So if we go back and think about two dimensions, if we've got two-dimensional space, we're very used to dealing with lines in two-dimensional space that continue essentially forever in both directions of the line. And when we've got a line in two-dimensional space, we can write the equation of the line as something like ax plus by equals c, where c is just a constant, so it's just some sort of value, and a and b are the coefficients of x and y. Now, a plane in 3D is kind of similar to that. So if we imagine the 3D axes, a plane is like a big flat surface within that three-dimensional space that extends basically forever and ever and ever in all directions, but it forms a two-dimensional flat surface. And it turns out that the equation for a plane looks kind of similar to the equation for a line in 2D, and we can write it as ax plus by plus cz equals d, and in this case d is the constant term. So how do we find these equations? So what I'm going to do is I'm going to draw a plane in three-dimensional space. Now, I've drawn that with edges, but planes don't actually generally have edges unless we say that they do. But what I'm going to do is I'm going to say that we know two things on that plane. So first of all, we know a point called P, which is on the plane. So we're going to say that P lies on the plane. And let's say I'm just going to call the coordinates of P little a1, little a2, and little a3. And I also know that if I've got a vector here called n is going to have coordinates capital A, capital B, and capital C. So n is normal to the plane. Remember, that word normal is the same as saying that it's perpendicular. So n is normal to the plane. Now, what I'm going to do in order to come up with an equation for the plane is I'm going to say, let's say there's some other point over here, and I'm going to call that capital X, and that's going to have the coordinates x, y, z. So big X is any point on the plane. And what I'm going to do is I'm going to draw a vector traveling from P to X. And I'm going to work out my coordinates of that. So Px, I'm just going to subtract the coordinates of P from the coordinates of X. It's going to be X minus A1, Y minus A2, Z minus A3. Now, what can we say about Px and n? Well, remember, n isn't tied to a particular point. N is just a vector that's normal to the plane. It can be anywhere we want. So you can sort of imagine that n could also be over here as well. And we can think, well, n and px are actually going to be perpendicular to each other. And that means that n and px, if we take the dot product of those two, we're going to get 0. So what does that mean? Well, let's expand that out. So remember that the vector n, sorry, I wrote it up here as if it was a point, but I should have actually written it as a vector like this. So if we take the dot product, we're going to multiply each of these, the components of px and n, and add them up. So big A times x, take A1, plus big B, y take A2, big C, Z take A3. And that's all going to equal 0. Now, if we expand that out and actually shift things around a little bit, what we get is we get AX plus BY plus CZ equals A times A1 plus B times A2 plus C times A3. And if we look at the right-hand side of that equation, these values here are all things that we know. They're the coordinates of P and the components of N. So you can imagine if we had those numbers, we could substitute them in, and we would just get one overall constant, which I'm going to call D. And if you look carefully, these two parts then are going to give us our equation of the plane. So here's an example. We've got a plane, just like we had before, and we're going to say that on that plane somewhere, there's a point called, let's call it A, and in this case it's going to be 3, 10, -5. That's the coordinates of A. That lies on the plane. And our normal vector is going to be 2, -1, and 3 is normal to the plane. Okay, so all we have to do to find the equation is we're going to take the components of the normal, and they are going to be the coefficients of x, y, and z. So we're going to say that 2x minus y plus 3z is equal to, and then we're going to write the same thing again, but we're going to substitute in the points from A. So 2 multiplied by 3 minus 10 plus 3 times -5. And if we work that out, we should get -19. And so the equation of the plane if we write it out in full, is 2x minus y plus 3z equals -19. So as you can see, it's actually a very simple process. All we've got to do is take the three components of n. They become our coefficients for x, y, and z. And then we take the coordinates of A and we substitute those in to that same equation to find our constant term on the right-hand side. Okay, I hope that helps, and good luck. Thank you.